Let's solve this complex question in 30 seconds. A man walks horizontally at 3 kilometers per hour in rain that is falling vertically at 4 kilometers per hour. What is the velocity of the rain relative to the man, and at what angle from the vertical must he hold his umbrella? The standard textbook method wastes precious time. You are taught to draw vector subtraction diagrams, write out the Pythagorean theorem to find the magnitude, and use inverse trigonometry to find the exact angle. That takes over a minute. Here is the 30-second shortcut, the 3-4-5 triangle rule. Since the horizontal speed is 3 and the vertical speed is 4, the relative speed, the hypotenuse, must be exactly 5. You don't even need a formula. For the angle with the vertical, the tangent is simply the horizontal over the vertical, 3 over 4. The angle whose tangent is 3 over 4 is the famous 37 degrees. Look at the diagram in the center. The rain vector is 4, the man's reverse vector is 3, making the red umbrella vector exactly 5. The angle with the vertical is strictly 37 degrees. That matches option B perfectly. Spot the 3 and 4, lock in 5 and 37 and move on.
Let's solve this complex question in 30 seconds. A car is negotiating a curved road of radius r. The road is banked at an angle theta. What is the optimum safe speed for the car without relying on friction? The standard method is a time trap. You are taught to draw free body diagrams, resolve the normal forces into n cosine theta and n sine theta, write out Newton's laws and divide equations. That takes way too long. Here is the 30-second shortcut, dimensional analysis elimination. Do not solve the physics, just check the units. The unit of speed is meters per second. Now look at the variables r into g. Radius r is in meters and gravity g is in meters per second squared. Multiply them and you get meters squared per second squared. To get speed, you must have a square root. Look at option D on the left. It has no square root, so the units are completely wrong. Cross it out immediately. Now, between sine, cosine and tangent, safe banking velocity is always derived using tangent theta. That instantly leaves option B as your only correct answer. Spot the units, remember the tangent rule and mark your answer in 10 seconds.
Let's solve this complex question in 30 seconds. Two trains of length 100 meters and 200 meters are moving in opposite directions at 36 kilometers per hour and 72 kilometers per hour. In what time will they completely cross each other? The standard method is an arithmetic trap. You write out separate conversions from kilometers per hour to meters per second, add the lengths and set up a relative velocity fraction. Too many steps mean too many chances for silly mistakes. Here is the 30-second shortcut, the relative sum and scale trick. Do it all in one clean mental line. First, the total distance is just the sum of the lengths, 300 meters. Next, total relative speed in opposite directions is 36 plus 72, which is 108 kilometers per hour. Now scale it instantly by multiplying by the magic fraction 5 over 18 to get 30 meters per second. Look at the center animation. 300 meters divided by 30 meters per second equals exactly 10 seconds. Option B is your correct answer. Sum the lengths, sum the speeds, scale with 5 over 18 and you are completely done.
Solve this complex question in 30 seconds. A conical pendulum of length L makes an angle theta with the vertical. What is its time period of revolution? The standard method is a massive time sink. You draw a free body diagram, resolve tension components, equate them to centripetal force and gravity, substitute the radius, isolate omega and plug it into the time period formula. That takes 3 minutes. Here is the 30-second shortcut, the effective height shadow trick. A conical pendulum is just a simple pendulum hiding in a shadow. Just find the effective vertical height h, which is simply L times cosine theta, and plug it directly into the standard simple pendulum formula. Look at the diagram. We drop a straight vertical line from the pivot to the orbital plane. That effective height is exactly L cosine theta. Plug that into T equals 2 pi times square root of height over G. That immediately gives us option B. Find the shadow height, skip the force balancing and save your time.
Solve this complex question in 30 seconds. A particle of mass m is whirled in a vertical circle of radius r. What is the exact difference in tension between the lowest and highest points of its path? The standard method takes at least 4 minutes. You have to write an energy conservation equation to find the velocity difference, write the centripetal force equations for both the top and bottom, and substitute everything to find the difference. It is an absolute trap. Here is the 30-second shortcut, the universal 6 mg rule.
For any vertical circular motion where the string does not slack, the difference in tension between the lowest and highest point is a universal constant. It does not matter what the initial velocity or the radius is. Look at the center diagram. The tension at the bottom is TL. The tension at the top is TH. The difference is permanently locked at exactly 6 mg. Option C is your correct answer. Memorize this constant, completely skip the giant derivation and secure your 4 marks instantly.
If you found this visual breakdown helpful, you need to put that knowledge to the test right now. Head over to neetapp.in or download the Neet app today. We have chapter-wise, concept-wise and level-wise MCQs from easy to moderate to hard waiting for you to master. Plus, you can take free full syllabus mock tests, grab premium NCRT-aligned study materials and enroll in our ultimate Neet crash course to supercharge your prep. Don't just watch physics, conquer it. Hit that subscribe button, click the link in the description and I'll see you in the next video.